To begin with, we're going to talk about the brief history of the steam engine. The first steam engine was created in the 1st century. It was more of a novelty than a practical machine. Centuries later, in the 1600s and 1700s, different inventors used steam power to pump water out of the mines. The biggest breakthrough came from James Watt in the 1760s and 1770s. His improvements made steam engines far more efficient and allowed them to power factories, locomotives, and steamboats. His work helped set the foundation of the Industrial Revolution.
Now looking at the thermodynamic principles, a traditional steam engine operates on a closed cycle that converts heat into mechanical work. First, a pump increases the pressure of liquid water. Next, the water enters the boiler where heat is added at a constant pressure until it turns into high energy steam. Then, the steam expands through a turbine or piston, producing mechanical work. Finally, the steam enters a condenser where it cools and turns back into a liquid water so the cycle can repeat.
For our prototype, we selected a 3D printable design and printed all the parts using a personal 3D printer. We did run into a few challenges while printing. At one point, a part lifted off the printer bed because we didn't use enough glue, which caused the part to warp. We stopped the print, added more glue, and restarted it so the piece would adhere properly. Once all the parts were finished, we began the assembly. At first, the parts did fit together, but the pistons were too tight and the flywheel wouldn't turn properly. To fix this, we took the engine apart and sanded down the pistons into the cylinder walls. After sanding, the movement became more smoother and we were able to assemble the full prototype. We also tightened all the air-related connections in preparation for testing because minimizing leaks would improve the importance to get enough airflow.
For testing, we used compressed air instead of steam as instructed. The idea was to let the air enter the cylinder, push the piston, and rotate the flywheel. However, our engine did not run successfully. Even with the compressor, we weren't able to achieve high enough pressure to overcome the internal friction and move the piston through a full cycle.
And to wrap up the project, our prototype did not fully operate, but we gained a solid understanding of how a steam engine functions both mechanically and thermodynamically. The project gave us hands-on experience with pressure-driven systems, tolerances, sealing, 3D printing challenges, and overall teamwork. Thank you for watching our presentation.
This is the testing. It's got a pump, and it's got the insert where we go through, where the air goes through, and hopefully it will turn it. So testing did not work. It moved a little bit if I built up enough pressure in it, but it didn't have enough pressure. It's got too much friction within the actual steam engine itself. And so I'm taking it apart right here to show you the inside of it. So I'll let Dominic hold that. But it's basically like a 3-piston, and basically the intake goes here where the air goes in, it puts through and flows up to the cylinders where it creates pressure. And so it's going to create a high pressure for wherever the piston at the top is, and it releases air on the other two. So it pushes down and it wants to keep rotating in a specific direction. But it's just, we tried to use some graphite and some WD-40 to kind of loosen the friction, and it helped a little bit, but it's not free-flowing enough, due to like plastic parts and loss of air, not tight seal. And so it's just, plus I don't have anything that has like a lot of pressure, a constant high pressure. So it's just, you can see it work a little bit, but not enough for it to continuously spin.
It will jolt and try to, but the friction just stops it right away.
Exactly.